When I use the term design process here, I'm referring to two types of design processes. The first is holistic or an overview conceptualization phase, where we identify the problem statement, and the second refers to some specific design of some element or object. There are similarities between both of these phases, and we will explore both. But first, let's examine the first holistic design process. In this process, we first identify the problem at hand through some problem statement. This problem statement then forms the conceptualization of the project. It's often very broad and not concerned with the specifics. So for example, by 1969, we want to go to the moon. It's very clear that the previous statement is not concerned with specifics. However, from this statement, it's possible to generate a number of ideas. These ideas help narrow the scope of work of the project because the ideas help refine what milestones need to be met, when they need to be met, and how they are going to be met. We can then test the functionality of these ideas using basic physics and mathematics. We will touch on this in a second. From these tests, which can be physical, for example, we can build an object, or numerical, we can run calculations, etc. Or the tests can be a mixture of both. So from these tests, we then select a solution, and this solution we then present in the form of some design report. And this obviously must tie back to the problem statement. So we must show with our results how we address the problem statement. So now let's take a closer look at our third step. That is the step concerned about testing our solution for each idea. As engineers, we must test the functionality of each idea that we generate, because our projects often involve serious consequences for the decisions that we generate. We must be able to quantify our solutions. So for example, if we want to consider a type of column to resist a certain force in our building, we must first know what these forces are. I've termed that the boundary conditions here. Once we know what the forces are, we then need to know how the object will fail. And if we know how it fails, then we can mitigate each failure mechanism and estimate the reliability of our object, which is a column in this case. Now let's just repeat this exercise with another example. Say I'm working on a project with the aim of delivering music to people, and I'm working on, say, the computer chip. I must first identify what material to construct the chip out of, what will the computing power of my chip be, where do I place my chip on the electronic boards, etc. And then how suitable is my chip material in relation to the operating conditions. So you can apply this type of methodical procedure to each one of your designs. That is, first look at the boundary conditions, then test the failure mechanisms, or how each element of your design is going to fail, and from that you can then explore the reliability of your object.